So I'm gonna go ahead and get started. So welcome to Get It Study Group week 4 of summer. So today is an exam review, but mostly I'm just gonna go through some of the questions in the practice exam. I wouldn't do like a huge exam review because I think Dr. Kasha already did it. So I mean, it would be better if you look at her notes and kind of like follow her review because it's definitely going to be more thorough than this one. So again, just like mention the checklist of things that we need to kind of like we must know for this exam. Just kind of make sure that you go through all the points and even with like the techniques in every single sections. These are important as well. There might be some other minor things like algebra and like some of the little tricks that I show you guys in the previous sessions of last week or the previous week. But other than that, most of the things here are like things that we must know. So for this first exam, so we have things like limit, continuity, and differentiability, and also some other things here. So first, the limit. Um, the general rule about limit is just we're gonna plug numbers in and find it. That's how we learn it in high school and like in previous classes. But here we have special product formulas. Um, So kind of the way to do this is like I think the first lesson, but I didn't actually go through. But you guys can also see Dr. Cash's note. And we have squeeze theorem, which is a very important part that help us finding like the limit of maybe things like sine x over x at x approaching 0, those kind of stuff. Then we have continuity. So for continuity, the thing that we all must know is the three important conditions to have a continuous function, which is that you have limit of x approaching a of fx exists. It has to exist. Then you have f of a also exists. And then you need these two to equal to one another to have a continuous function at that point at x equal a. Then we have a very important one, the intermediate value theorem. So there's a questions in the practice exam. I think it's quite similar to how Dr. Cassius go over it in the previous semester. I have no idea about like how people perform on that one because it looks like most of the people that I've seen get it right. So I think it might be like an easy one for you guys. So I didn't actually include it in this exam, like this exam review. But if you have any questions with doing that questions, I think it's question like 17 or whatever. But if you have any questions with that, feel free to email me. I'll be more than happy to answer it because it's like a long one, so I didn't want to like take so much time for you guys. But okay, and then we have one side limit and absolute values. So I think I went over absolute value in week 2 Get It Study Group. So if you have any problem with that, that'll be better if we look at that one because it's more like I spent a good 20 minutes talking about absolute value. And then we have limit using the definitions of derivatives. So this is kind of like a tricky one. So but also like another way to find limits. So when you're given a limit and it looks a bit weird, so say like limit of x to the 1,000 minus 1 over x minus 1 is one of my example in week 2. So it's like if you're given this and limit of x approaching 0 or infinity, then you might want to think about maybe it might equal to f prime of at 1 with fx equal x to the 1,000, something like that. Then yeah, using derivative to solve it, which we learned like the formula where we can take derivative of x to the n already. So that'll be easier. Something we don't quite talk much, but you must know kind of just the general definition is the type of discontinuities. So jumped, removable, or there's another one which is like just like a, I don't know how to name that one, but there's another type. But yeah, those 3 types of discontinuities. And then we have a small part, which is discontinuities or power functions of negative exponents. So things like x to the negative n, like x to the negative 2, which is this 1 over x squared. This one is going to be discontinuous when x equals 0, this kind of stuff. And then we have differentiability. So when we talk about differentiability, we talk about derivative of a function at a point and derivative of a function as the function. So kind of know that and like their definitions, and also after we've done a while, we have some formulas that we can take, which is like including this one. And then we have the relationships between differentiability and continuity. So a differentiable function at a point will definitely will means that it's continuous, but a continuous function is not guaranteed to be differentiable. So that part, if you want to review it, you should, because the relationship can be a little bit complicated there. And then we have things like the derivative rules. So we have product, quotient, chain rule, and power rule. There's something we call the failure to be differentiable. So things like if you have graphically, as I said, if we have like a sharp point, or like when we have the absolute value function and the graph actually make it look like there's a kink in there, then usually that shows the fact that our function is not differentiable. But you can also find it as a function if you can prove the fact that limit of, or you can prove like f prime a does not exist using maybe like the limit, the definition of derivative as a limit. Then we also have things like implicit differentiation. So this is to find y prime of those function of x and y that we cannot just separate into y equal fx. So things like a circle function, x squared plus y squared, maybe like 25, or r squared. Then those kind of stuff we have to use implicit differentiation. Then we have tangents. So a bunch of things about tangents. So a must-know thing is, what is the general form of a tangent line? So this is a question that I always ask you guys when we have like a tangent problem. Then finally, we need to understand what is the basic meaning of derivative. So graphically, it's the slope of a tangent, but we can also apply it in many other fields, especially when we talk, like I think we spend the entire sessions of 2.7 talking about derivative application in kinematics. Things like velocity is the derivative of position, and acceleration is the derivative of velocity, and so on. And then how to use related rates to solve problems, which I think is section 2.8. So a bunch of stuff to review. So if you miss any of them already, please feel free to maybe stop this or review after the sessions. So now we're gonna go ahead to do some of the questions in the practice exam. It's question 2, evaluate the limit if the limit exists. We have limit of x approaching 2 plus x squared multiply 2 minus x divided by absolute value of 2 minus x. So again, if you have any questions anytime as I explain it, if I'm going too fast or too slow, feel free to put it in the chat room and I will adjust the speed. So for this one, when we have the absolute value, the first thing is that we try to get rid of it to figure out kind of simplify the expression. So to see it, to simplify it, we have to see what is the sign of the expression inside the absolute value. So at x approaching 2 plus, x approaching 2 plus, then 2 minus x is gonna approach 0 plus, because it's gonna be a very small number, and it's negative because 2 is minus a number bigger than 2. 2 plus, it means it's approaching on the right of 2, which is a slightly bigger number than 2. So 2 minus x is going to approach 0 plus. So if you want to break this absolute value side, it's going to be x minus 2, the reverse. So this is where I mentioned in week 2 lectures is which you review, which is absolute value of A is going to be A itself if A is bigger than or equal to 0. And if A is smaller than 0, then it's going to be the absolute value of that, which is x minus 2. So in this case, then we have limit of x approaching 2 plus. These two kind of cancel out and it leaves a negative back. Therefore, we have this one is going to be negative 4. So nothing really tricky. The most tricky part is how to resolve this absolute value. Before I proceed to the next questions, is there any problem with this one so far? Even if you understand it, please put it in the chat, so like yes or no, so that I know like if I should proceed further. Okay, so let's go to the next one. Same, evaluate the limit if the limit exists. So we have limit of x approaching 0, sine 2x over x, cosine x plus secant x. Now to solve this one, we try to use some of the relationships that we learned earlier, things like limit of x approaching 0, sine x over x equal 1, or limit of x approaching 0, I think it's like 1 plus, not 1 plus. Or like tangent x over x is also 1. Or we have, I think, 1 minus cosine x over x, I think. I don't remember, but it's like the second, I think it's also in week 2. But yeah, but we don't need to use this. We only need to use the first one. So to solve this, first of all, because we have sine 2x and then x down here, it doesn't really help. So there are two choices that actually we can do. Is that you can rewrite this one as limit of x approaching 0, sine 2x, 2 sine 2x over 2x, multiply 1 over cosecant x plus secant x. Now, because x approaching 0, so then you have limit of sine 2x over 2x is also going to be 1. Because when x approaching 0, 2x also approaches 0. So then basically we have this thing, it's just going to equal 1. So we're going to have this one is limit of x approaching 0 to cosecant x, cosine x plus secant x, which is going to be 2 over 2, which is 1. Or we can do it the other way, is that we can write this one as, use the double angle formula. We have sine 2x is going to be equal to sine x cosine x, which is going to give us this sine x can pair up with this x over here and get the limit to 1. And then we have cosine x plus secant x. Now, then we're going to have this equal 2 cosine x secant x plus cosine x, which is going to give us 2 over 2 as well, which is 1. And this makes sense now because both approach matches with one another for the final result. So yeah, this is how we solve this. So 2 ways you can do it, because here when x approaching 0, 2x also approaches 0. That's how you have this one. So I think this one is kind of like the tricky part, is just to be able to rewrite it either in this way or we can rewrite it this way. It doesn't really matter which one. As long as you keep the algebra correct and don't forget any numbers, then you should be able to get the answer. Okay, so I think this one should be good. Not too many things. Now we'll go to the next one, is question 5. So this one is, again, not challenging as well. Just remember, just kind of like review a little bit about the 3 important conditions to get a continuous function. So it's asking for what value of a constant c is the function f(x) continuous on negative infinity to positive infinity. Now, we have f(x) is equal sine cx over 3x if x is smaller than 0. So it's already continuous from infinity to 0, negative infinity to 0. And it's equal to another one, cx plus 1, if x is bigger than 0. And again, it's also from 0 to infinity. So it's already continuous on this interval. because this is a polynomial and it's continuous everywhere. But here we define it only as when x is bigger than or equal to 0. So this one is continuous here and here. So the important point that we need to take care about is when x is equal to 0. So let's look at the three conditions that we mentioned earlier. We need the limit of x approaching 0 of fx exists. We need f of 0 to exist as well. And we need these two quantities to equal to one another. Now, let's look at this. We have f of 0 is when x is equal to 0. Then you plug in 0 here, which is going to be give us 1. Then we find the limit of x approaching 0. Now we have two expressions on the two sides. So we're going to find 0 plus and 0 minus. So this one is going to equal, when 0 plus, we're going to use the second expression, which is cx plus 1, which is going to give us 1. And then we have limit of x approaching 0 minus f of x is going to equal limit of x approaching 0 minus. We use this expression, sine cx over 3x. Now here, this is where we have limit of x approaching 0 plus. Now again, we use limit of x approaching 0 of sine something of x divided by something of x is equal to 1. So I can rewrite this one as cx over cx. There's a 3 that we have, and we multiply the denominator by c, so we also multiply the numerator by c. And so as x approaching 0 plus, cx also approaches 0, and so this thing is going to give us 1. Therefore, this entire limit is going to give us just c over 3. And then the third conditions in the continuous thing is that we need these three quantities to equal to one another. So we need limit of x approaching 0 plus of fx equal to f of 0 equal to limit of x approaching 0 minus f of x, which is now going to give us c over 3 equal to 1 or c equal to 3. And again, that's my final answer for the questions. So again, nothing really important. Just make sure that you guys remember those three conditions and be able to derive this. I feel like this is like a classic questions for all midterm 1 from Dr. Kasha. So I think definitely in the final exam, there should be one of the questions this type. Now, let's go to question 8. So this is where things get slightly bad, but it's not really challenging yet. It's just when it's just slightly increasing the level. So this is where I said another way to find limit is put it in back to the form of derivative. So here clearly you can see like this is kind of like matching up with the definition of derivative, which we have x plus h minus f of x divided by h. Or you can, instead of x, you can have 8 here. Then that will become the derivative at a point. So in this case, we have a equal pi over 3. And f of x, it looks like it's just going to be cosine of x. Therefore, here we have is equal f prime of pi over 3 with fx equal cosine x. Now, based on what we learned so far about derivative, we can take this derivative with using the formula we have. I think it's either 2.5 or 2.6. But derivative of cosine x is negative sine x. And you have f prime of pi over 3. Just plug pi over 3 in, which is going to be negative sine pi over 3. And what it's giving us is negative. So sine of pi over 3 is square root of 3 over 2. So it's negative square root of 3 over 2. And also the answer for this question. So again, this is where we another way to find limit. So let's go to question 9. Find the second derivative. So I think a lot of you might not have much experience with this one, or like didn't do many of these, because I think most of our practice problems and example problems is just focus mostly on the first derivative. So this is a good practice here that we get a chance to find a second derivative. So the second derivative is basically you take the derivative of the first derivative. So when you have y equals sine x multiply cosine x, by the way, we have product rule here. So take the first derivative is the derivative of the product is going to give us cosine x multiply cosine x plus sine x multiply negative sine x, which is going to give us cosine square of x minus sine square of x. You can keep it this way to continue to find the second derivative, or I would prefer putting it into the form of cosine 2x. This is another double angle formula, just like make our life easier, because I mean, just imagine you're taking derivative of cosine square and then sine square. It's much more challenging than just taking derivative of cosine 2x. So if you take the second derivative, I'll just do it both way in case you guys keep it. So let's do the first one first. When it's the derivative of cosine square and minus sine square, which is going to give us 2 cosine x multiply derivative of cosine x is negative sine x. And then another one is negative sine multiply cosine. So it gives us negative 4 sine x cosine x, or it's going to give us negative 2 of sine 2x. Because sine 2x is 2 sine x cosine x. Another way, we do the cosine 2x and take derivative of that, which is going to give us just negative 2 of sine 2x. Just one step, and it solves a lot of time. But it's up to you guys of how you guys want to approach the problem. The answer is exactly the same. It's just how long we want to spend time on it. Yeah, nothing really tough here. So yeah, don't freak out about the exam if you are. It's not too challenging at all. Now we have, I think, 2 more questions. Oh, not 17 then. I think it's question 18 is the intermediate value theorem, but I'll leave you guys on that one. So question 13, find all of the x coordinates of the points on this curve where the tangent is parallel to this line. Okay, first of all, when we have a tangent, we need the general formula of a tangent line. So general tangent line is where we have y equal y prime at x0, x minus x0 plus y0. Now, the only thing we care about here, the special condition, is that the tangent have to be parallel to the line, which means we need y prime of x0 equal to negative 12, which is the slope of this line here. So when the two lines are parallel to one another, they have the same slope. So basically, the question is asking you to find the value of x that you have f prime of x equal to negative 12. Well, given this polynomial, let's find what is the derivative of f, which is 6x squared minus 6x minus 12. And to find what is going to give, you said this one equal to negative 12. So what we have is 6x squared minus 6x equal to 0. Or we have x squared minus x equal to 0. You can also rewrite as x multiply x minus 1. So we have two values that have we have 2 points that have the slope that have the tangent parallel to this line, which is x equal 0 and x equal 1. So that's why, I mean, when we write down here, I notice a lot of people just like said, okay, because you have 6x squared minus 6x equal to 0. So x is just going to be equal to 0. A lot of them miss the second solution, so make sure that you be careful here. Don't just like, okay, I know 0 satisfied it, but the question is asking find all of the x coordinates, so make sure that you don't miss any solutions at all. Okay, hope I'm not going too fast on this one. Again, if you have any questions or like cannot follow what I'm saying, stop me. Other than that, I'll go through 15 now. Given this function, okay, we have f of x equal to 3 g of f of x. Determine f prime of 4. Okay, in this kind of question, what I would recommend you guys doing is do not look at these numbers. It's super confusing because you don't know what numbers you're gonna need yet unless you write down what is big F prime of 4 and figure out what values that you need. So let's get started on here. So when we take this derivative, which is going to be 3g prime of f of 4. Now, when we look at this, first we need what is f of 4. So f of 4, now we know what we need here. F of 4 is 4, so we have 3g prime of 4. Now we need g prime of 4, which is going to give us 5, which is 3 multiplied 5, which is 15. So that's why I'm saying, in this kind of questions, do not look at a bunch of numbers. It's super confusing. Try to write down what you need here, and then plug them, like, just look for that number in this list, and that's gonna make your life so much easier and make less mistake instead of just trying to relate them immediately. Try to start from whatever they're asking you so that you kind of like save your time and also increase the accuracy of what you're doing. Yeah, so it's just not a it's kind of like a new one. So I guess some of you might struggle through this, so I put it in here. But if not, I mean, I think you guys in the good shape for the exam. Now we have the last questions. It's question 17. I think this one is implicit differentiation. So we have y squared plus x minus 1 squared equal to 1. And it's asking what are the x coordinates of the points where y prime is not defined. Now, what exactly is y prime? So we have to use implicit differentiation to solve for this. So take derivative of both sides with respect to x. We're going to have 2y multiplied dy over dx. Or I'll just write y prime. But then you have 2x minus 1, derivative of x minus 1 with respect to x. And this one is just going to equal 0. Now I have 2y multiplied y prime plus 2 of x minus 1. Derivative of x minus 1 with respect to x is just 0. It's just 1. So you can ignore that part. Therefore, we have y multiplied y prime is going to be equal 1 minus x. Now, or you can write y prime equal 1 minus x over y when y is different from 0, because that's a fraction. Therefore, the way that we said it is that y prime is not defined when y equal to 0. So basically, looking at this function, you just try to find x so that y equal to 0. So here we have y multiply y prime. This function, you have y squared plus x minus 1 squared equal to 1. So when y equal to 0, you have x minus 1 squared equal to 1. Or you have x minus 1 equal to 1, or x minus 1 equal to negative 1. Remember, there are two possibilities here. So either x equal to 2 or x equal to 0. So at these two values, y equal to 1, and clearly you can plug it in here when you have y equal to 0, and maybe x equal to 2 or x equal to 0. This thing on the right is going to be different from 0, and this thing on the left is equal to 0. Obviously, a number, 0 cannot be equal to a number that is not 0. That doesn't make any sense. Therefore, our answer is correct. So here I'm also showing you guys a way that you can check it. So if you find these two values of x here, you can plug it back into this function for y equal to 0 and that value of x. If you have two different numbers on the two sides, then that makes sense because your y prime, like that equality wouldn't make sense. So, which means at that value, y prime is not defined. So, are we clear here? This one is slightly good, like interesting, but not hard at all. Any questions so far what I'm doing? Okay. If you don't have any questions, I think that's all I got. Okay, hang on. Let me look at. Okay. So yeah. So I will say good luck for your exam and I'll see you guys next week. So have a great weekend and have good exam, guys. I'll end the meeting here.